All right, welcome everybody. It's now 9 o'clock. So we're going to start our live stream momentarily. So if you are online, yeah, I am in a different branch today. Yeah, I was asking you, right, whether, Justin, whether you wanted to come by. If you wanted, I would have stayed in Bishan. But since you didn't want, I came to set up here at Kembangan today. But Jasper, another student, said he actually wanted me to sit in. I would, if I had known, I would have stayed in Bishan. But now next week I can stay in Bishan for you guys. Right. So anyway, let's begin our session. So today we are going to revise what is the theory of basically international trade and focusing mostly on the theory of comparative advantage. So I'm going to assume you guys have forgotten most of the details. Wait, Cheryl is asking a question. Cheryl is asking whether we're going to explain how to use the graph to explain C theory. Yes, definitely, Cheryl, that is actually part of the session. Right, today we first use the table to understand the concepts. Then we'll look at how to use the PVC diagram, because in the exam, the PVC diagram will be a much more easier way to illustrate the comparative advantage. Now, so for those of you who are already online, right, I'm going to talk about first, we will use numerical example for understanding purpose. But when it comes to the actual exam, you don't have to actually use a numerical example to illustrate. You can just summarize the idea. All right, so first, without further ado, let's begin. So to understand the theory of comparative advantage, right, the first thing you need to do is to recognize that there is a concept called absolute advantage. What does absolute advantage mean? Absolute advantage, right, basically says that when a country is able to produce a good at a lower cost than another country, then this country has an absolute advantage. So it is about raw productivity. If country A has higher productivity than country B at producing good X, country A has an absolute advantage over country B in good X. If country A have a higher productivity and country B in good Y as well, then country A has absolute advantage in both good X and good Y. So a country can have absolute advantage over another country in lots of different goods. So what is the key point, right, to the idea of comparative advantage? Comparative advantage key idea, right, is that we are trying to look at how is it that two countries can come together and enjoy mutually beneficial trade, even if one country has an absolute advantage over another country in production of both goods. So the very important key point, and so CA theory, right, explains how two countries can enjoy mutual benefits. The key idea is even if, right, one of them has absolute advantage in both goods. So because of the idea behind that you want to show that even if one country has absolute advantage in both goods, right? The way we present this model has to start off with a situation where you have one country better than the other country in both goods. So to use the numerical example, my most favorite numerical example, right, is to choose a two country, two good model, where my two country is a developed country like the USA, right, and a developing country, right, Vietnam. And the two goods I like to use will be a manufactured good like guns and agricultural output, right? Agricultural output like roses. So I have two countries, USA and Vietnam, producing two goods, guns and roses. Then you can already see where I'm going with this, right? So Guns and Roses is the name of a popular rock band, right? So yeah, I'm trying to be funny here, but I like the band. I think some of you do too. Right, so what you see here on the table, right, is this thing called output per unit labor. So think of it as per worker, how many units of guns can America produce? Let's say per week, for example, right? So per worker per week, right, America can produce 25 guns, while Vietnam can only produce 10. So raw productivity, each worker in America can produce 25 guns, each worker in Vietnam can produce 10 guns, right? Now, if you go to roses, America And Vietnam, right? America has lower productivity than Vietnam in producing roses. Now we have a problem. What you see here, right, is America, USA, has AA in guns, while Vietnam has AA in roses. This is not CA theory territory anymore. In order to show that CA, to illustrate the thing that CA is trying to illustrate, we need to get it to a place where one country is better than the other country in both goods. So this starting table doesn't work, right? So this starting table doesn't work. What we need to do is to create a new version of this table where one worker in America can produce more guns than the same worker in Vietnam. One worker in America can produce more roses than Vietnam. So the starting table must have this starting point, where one country is better than the other country in terms of productivity, in terms of absolute advantage in producing both goods. Now, why is one country better than another country? Could be a lot of reasons, right? Could be quality of labor, right? Level of education, level of skills, amount of infrastructure in the country, level of technology in the country. There could be a wide range of different reasons that could explain the sources of the absolute advantage. When we're looking at this numerical example, we're not interested to at this point, right, answer the question of where this comes from. We're saying, okay, suppose there was absolute advantage where country A or USA in this case has absolute advantage over Vietnam in both the goods. How can we use this model to show that they are going to be mutually beneficial? All right, so to do that, right, the first thing we need to do is to add some simplified assumptions. The simplified assumptions that we have made, right, is that the countries have the same amount of resources to begin with. Now, that's blatantly untrue in the real world. Countries don't have the same amount of resources. This is why it is called a simplifying assumption. We're making things simple and say, suppose that I have two countries that have the same amount of resources to begin with. For purpose of illustration, let's imagine that the only resources they have are workers, called labor, and each country have 8 units of labor, right? Whether you call it 8 workers or 80,000 workers or 8 million workers doesn't really matter, right? So 8 units of labor. We also make another simplifying assumption that each country initially devotes half its resources to the production of each good. That means Vietnam puts in half the resources to produce guns, half the 8 units of resources to produce guns, half the resources to produce roses. So does America. So then from here, we create a little table. Now, you have a yellow color table at the corner to help us remember that America, one worker produced 25 guns, Vietnam, one worker produced 10 guns. So if America now devotes half of its 8 workers to produce guns, right? Then America, one worker produce 25 guns, 4 workers will be 4 times 25. America produce 100 guns. America devotes half its resources to produce roses. So one worker produce 200 roses, 4 workers produce 800 roses. Vietnam does the same. Take 4 workers to produce guns, 4 times 10, 40. And Vietnam, 4 workers times 150, that gives us 600. So what we have here is, assuming for simplicity, each country initially devotes half its resources to the production of each good, and assuming again for simplicity, the two countries have the same amount of resources to begin with, this is our output of guns and roses in the two countries. And now we assume further that there are no other countries, right? The whole world only has 2 countries on this hypothetical planet. All right, so then the world output now for guns will be 140 guns, which is the American production plus the Vietnamese production, and roses will be 800 and 600. That gives us 1,400 roses produced in the world. Right, so this is the initial state of the world. In a hypothetical world, we say, okay, suppose we have this situation where America is better than Vietnam in guns, America is better than Vietnam in roses, and they have the same resources and each devote half the resources in each good. This is our starting point. So we want to show that if each country specializes according to comparative advantage and voluntarily traded with each other, we want to show that there's mutual benefit. Now, how do we go about showing that? All right, so let's work out who should do what, right? So again, I reproduce the table here about how this reproducing table 1 now. Each country devotes half the resources already. So 100 guns for America, 40 guns for Vietnam, 800 roses for America, 600 roses for Vietnam. So what we want to do is we try to determine who has a comparative advantage in what group. So first thing we begin with, right, is to look at this equation. 100G equals to 800R. I'm looking at this number, 100G versus 800R. What does 100G equals 800R means? It means that assume if America can use 4 workers to make 100 guns, it can use 4 workers to make 800 roses, then the cost of producing 100 guns and the cost of producing 800 roses are the same. So that's what this equation is saying. The 100 guns and 800 roses are equal in terms of the resources needed to produce the goods, right? The resources needed to make 100 roses is exactly equals to the resources needed to make 800. I'm sorry, resources needed to make 100 guns is exactly the same as the resources needed to make 800 roses. Now I simplify this equation, going to the lowest common multiple, 100G equals to 800R can be simplified into 1G equals to 8R. Putting this in words, right, I can now say that every 1 gun America makes, right, would require an amount of resources that could have been used to produce 8 roses. Repeat, every gun that America makes require an amount of resources that could have been used to produce 8 roses, right? So the opportunity cost of producing guns, right? Opportunity cost of producing guns in America is 8 roses. Right, hang on. Am I getting messages from somebody? Oh, okay. All right. So this is the way to identify the opportunity cost of producing 1 gun in the USA is 8 roses. Continuing now, in Vietnam, let's take the same comparison. The resources used to make 40 guns is the same as the resources used to make 600 roses because they also 4 workers, right? So 40G equals to 600R, therefore scaling down 1G equals to 15R. The opportunity cost of producing 1 gun in Vietnam is now 15 roses. Now compare this to America. America, every gun they make requires the resources needed that could have been used to make 8 roses. So the op cost of every gun is 8 roses. Vietnam, the op cost of every gun is 15 roses. So we conclude then that in America, the opportunity cost is lower than Vietnam when it comes to making guns. So USA has a lower op cost than Vietnam in the production of roses, of guns, sorry. So then from there we say that USA possess the comparative advantage in the production of guns. Now by now, all of you would have learned this in school, right? That a country is said to have a CA in that good if it incurs a lower op cost than the other country. So you can see America's op cost of guns is 8, Vietnam's op cost of guns is 15. America has lower op cost than Vietnam. America has a comparative advantage in terms of guns. Okay, here's where it gets really important, really important. Please follow as closely as possible. The reciprocal of 1G equals to 8R is 1R equals to 1 over 8G, right? And that means I can rephrase this statement as saying that the opportunity cost of producing 1 rose in USA is 1/8 of a gun. So every 1 gun I make require resources that could have been used to make 8 roses. Conversely, then every 1 rose that America makes, right, requires resources that could have gone into making 1/8 of a gun. Right, so this can be rephrased as such. This is simply the reciprocal. Then the opportunity cost of producing 1 gun in Vietnam is 15 roses. The reciprocal of this equation is 1R equals to 1 over 15G, meaning that the op cost of producing 1 rose in Vietnam is 1/15 of a gun. So now you can see something interesting. 8 is less than 15, so the op cost of guns is lower in America, but 1/15, right, is less than 1/8. So if America has a lower op cost in guns, it must, mathematically speaking, right, have a opportunity cost in higher opportunity cost in guns, in roses, right? That means it cannot concurrently in a two country model, America or any country for that matter, cannot concurrently have the CA in both goods. I can only have the CA in 1 good. The other country must have the CA in the other good. Now, what's the important implication here? The important implication here, right, is that a lot of students, right, always like to make this argument in the exam that, oh, one of the events that could cause my economy to do badly is the loss of comparative advantage. Because I lost comparative advantage, it creates structural unemployment in the economy. Wait, you don't lose CA or in a good and period, right? You don't lose a CA in a good and full stop. When you lose the CA in a good, you will gain a CA in another good, right? So the nature of the comparative advantage is your opportunity cost of this good has now become lower than other countries. That's gaining a CA, right? You must have mathematically be having a higher cost in some other good, right? Then you start losing CA somewhere else, right? So instead of saying loss of CA, present it as a change in comparative advantage, that you gain CA in one good, you lose CA in the other good, and this is your source of structural change. And that structural change requires workers to move from one industry to another. And because of that immobility of labor that might exist in the country, that's how structural unemployment comes about, right? So this is the understanding behind why we cannot say loss of CA as a reason for causing BOT deficits or structural unemployment. It should be change in CA, right? So that's the underlying principle behind the explanation. All right, so then from here, let's move on. So now I know that US has a CA in USA's CA is guns, and Vietnam's CA is in roses. And I say, okay, let's specialize then. So let's go over to specialization. So America should do guns, Vietnam should do roses. Now watch carefully on the board. So America should do guns, so all the workers here should move over to do guns, right? And for Vietnam, they should do roses. All the workers should move here to do roses. Now, if Vietnam, 4 workers can make 40 guns and 4 workers can make 80 roses, 0 workers making guns will have 0 guns left. But 4 workers make 600 roses, 8 workers will make them exactly 1,200 roses if we assume that there is constant returns to scale. That if I put 4 workers, I get 600, 8 workers will give me twice the number of workers, right? I should get exactly twice the number of resources. So that gives me 1,200. Now, a lot of students say, why not assume IEOS, right? Because if I assume IEOS, this number will get larger, right? If I assume increasing returns to scale, or rather IRTS, increasing returns to scale, this number will be greater than 1,200. Then my gains from specialization, right, would have partly come out of comparative advantage and partly arise from increasing returns to scale or economies of scale. In order not to mix up the gains from IRTS, right, I'm going to assume away IRTS. I'm not saying there isn't, I'm saying that let's pretend that there isn't. Let's mathematically remove any IRTS so that even if we show that there's a net gain, right, the net gain must be coming not from IRTS, but instead coming from comparative advantage. So we assume constant returns to scale. Now, the second assumption, right, is about why there's perfect factor mobility. It's because, right, when I move all my workers away from guns to roses, right, perfect factor mobility ensures that all my workers can go over. But if there was, let's say, factor immobility, right, one of these guys might become, oops, sorry, we went too far now. Please come back up. One of these guys, right, might become structurally unemployed, right? So he might, sit on the bench, right, and be unemployed for a while. So to ensure that every one of them crosses over nicely to this other industry we need to assume perfect factor mobility. And to make things neat and tidy, we also assume that as the industry buys more labor, there isn't a competition for labor that will drive up wage rates and labor costs and other factor prices. So let's keep all this stuff that can distort our outcomes away. Let's assume none of this will change, right? So then I now have a neat solution. 4 workers to produce guns, 4 workers to produce roses, I get 40 and 600. 8 workers produce roses, then I have 1,200 roses and 0 guns. Then now for America side, no workers are producing roses, so I have 0 roses, and all the 8 workers producing guns, assuming the assumptions hold, I have 200. Now I have a little bit of problem. What's my problem? My problem, right, is that if you add these two together, right, I now have 1,200. I now have 1,200 roses and 200 guns. Is the world happier? Okay, so this gets a little tricky. So we now have to assume, right, that guns don't cause negative externalities and guns don't kill people, okay? Guns protect people, right? So with more guns, the world is arguably happier, right? Because we like our guns, or at least if I'm Republican, right? We like our guns. Okay, actually, to be fair, Democrats like their guns too, right? So never mind. Suppose we like our guns. So with 140 guns in the world, we are happy. With 200 guns, the world is happier. But we have 200 fewer roses than before. So the world is happier or less happy now with roses? We're less happy with roses. On the whole, are we happier or less happy now that we have more guns and more roses? Then the answer is we don't know, right? We don't know because it depends on how much we like our guns versus how much we like our roses. If we like our guns more than we like our roses, do we like our guns sufficiently more such that that 60 extra guns is going to give us a total increase in consumer welfare, more so than the loss in consumer welfare for having 200 roses? Well, we need some more information. So we don't know for sure that this is better. So how then do we get out of this uncertainty situation? To get out of this uncertainty situation, then we say, okay, how about, right, we tell the Americans, can you guys don't fully specialize in guns? Help up the production of roses a little bit. Send back two fella, right, to producing guns, to producing roses. That means you partial specialize in guns. Instead of all 8 workers here, channel 6 workers to specialize in guns, leave 2 guys behind to make roses. Then in this case, my roses number, instead of dropping from 800 to 0, it drops from 800 to 400, right? 4 workers, 800, 2 workers, 400. This way, I get a number that is 1,600, 12 plus 400 is 1,600. And this side, instead of 100, 200, I get at 150, which now gives me 150 plus 0 equals to 150. I get more guns in the world and more roses in the world. And then we are clearly happier, right? We are happier because we have more guns than before. We are also happier because the world as a whole got more roses before. If you're getting more of both goods, assuming marginal utility is always positive, it means every additional unit of the good produced is just going to add on to total happiness, then the world is clearly happier. Let's not get into this debate about whether more guns is a good thing or bad thing. It's just a bloody example, right? You can just change it to guavas and I don't know, rambutans, right, for the matter, right? So you can change it to anything else for the matter. So don't get disturbed by the fact that it's guns, right? Just cute that it's called guns and roses. All right. So now we have shown, right, with specialization according to CA, it is possible for the output of both goods in the world to now have gone up. So we have a net 10 guns extra and a net 200 roses extra. Together, these are called the gains from specialization, right? According to CA, right? If we specialize according to CA, we get gains from specialization. We get more output of both goods. So you say, okay, now that we have more output of both goods, right? Does each country benefit more? Because now at this point, it's just the whole world is happier. How do I get to a point where each country, right, will voluntarily agree to, okay, let's do this trade thing. It must be mutually beneficial. So in order for it to be mutually beneficial, we must find a way for the two countries to exchange those guns and roses, right, in a way that makes it worth their while. So from the American side, right, remember the American side are the one specializing in guns. So they have now way more guns than they used to have, but way less roses, right? So what the Americans want to do is to sell guns, right, to the Vietnamese and say, okay, hi Vietnamese, I have some guns and I see you got some roses there. Can I sell you some of my guns in exchange for some of my roses? And the Vietnamese little guy will say, oh, sure, you know, I have roses, right? I would like to have some guns. So let's trade, right? So the Americans say, okay, how much, right? How to change? So the Vietnamese guy maybe say, well, how about I offer you, right, for every gun that you sell me, right, I'll give you 7 roses, for example, right? For every gun that you give me, I will give you 7 roses in exchange. Then the American think about it and say, wait a minute, to make a gun, I had to free up resources from roses production such that I had to give up 8 roses to get just enough resources to make 1 gun. And now if I sell Vietnam my gun, in exchange I only get 7 roses, then Americans will say that doesn't make sense, right? I'm worse off. So in order for America to be willing to trade, right, not benefit, just at least willing to trade, they must get back the number of roses that it matches their op cost. So America requires, right, that Vietnam must pay them 8 roses at least, right, for every gun before America is agreeable to trade. So this is the American condition for trading. Now Vietnam, on the other hand, makes roses. Every rose that Vietnam makes, right, they give up resources, they took away resources from gun production such that they have to lose, when they lose every 1 gun, they free up enough resources to make 15 roses. If they were to sell the roses to America, they surely wouldn't want the roses, they surely wouldn't want to have to pay more than 15 roses. So the inequality that has to hold for the Vietnamese, right, must be 1G, must be less than or equals to 15R. Now you can look at these two inequality and realize that, hey, there is a possibility of mutual benefit, right? If the Americans want has to be more than 1G has to be more than 8R, more than equal to 8R, Vietnamese say, I'm okay, right, as long as it's no more than 15. So they have a range of 8, 9, 10, 11, 12, 13, and 14, right? So there is a range of terms of trade within which the two countries can find a mutually beneficial arrangement to trade with one another. Right? So where would they trade? So let's now arbitrarily, right? Suppose now that both countries have arbitrarily agreed to trade at a number of 1:10, right? I'm just randomly picking a number within this inequality range, right? Between this inequality range, I'm arbitrarily picking a number of 1:10. Say, okay, this is 1:10. What is the then how will they trade? Then we additionally assume that America will export 45 guns to Vietnam and go at the rate of 1:10 means they will get back 450 roses, right? So okay, so let's look at my table now. America has 150 guns now. If it were to sell 45 guns to Vietnam, so America now must subtract 45 guns. Vietnam must add 45 guns. So what's the total? Total America now has 105 guns left. Vietnam, 0 production plus the 45 they imported from America, they got 45 guns. Vietnam now, at the rate of 1:10, will have to give back 450 roses to America. So America add 450 to their own production of 400. So America now have 850 guns, while Vietnam has 750 roses, sorry. America has 850 roses, while Vietnam has 750 roses. So this would be the consumption they get to enjoy after they trade with each other. Are they better off? Well, you can look at this table now, right? Clearly, compared to table 1, right, the pre-specialization table, America now has 105 more than 100, right? So they're better off in guns. Vietnam is better off in guns. America is better off in roses. Vietnam is also better off in roses. Both countries are better off in both goods. Right? So then now we have a situation where everybody's happier, right? Or at least from a country level point of view. Sorry, I shouldn't say everybody's happier. Maybe some Americans are less happy. Maybe some Vietnamese are less happy. But in theory, both countries as a whole are happier, right? But we need 2 additional assumptions. We have to assume that there are no transport costs. Because when America makes guns, right, and have to ship these guns to Vietnam, ship the 45, when America has to ship 45 guns to Vietnam, right, I may need truck drivers, right? If one of these guys had to become a truck driver, then I wouldn't have enough. Okay, sorry, America and Vietnam cannot travel by truck. Somebody has to sail the ship, right, from America to Vietnam and bring the guns over. And some guy from Vietnam, right, may have to become a sailor, right, to bring the goods, right, to ship the goods to America, to ship the roses to America, or fly the plane to America, right? Then if I pull away people for transportation, right, the gains for specialization I calculated earlier may not fully manifest, right? So in order for us to have these numbers work well, we're going to have to assume that there are no transport costs. And then once the goods reach each other's borders, we also have to further assume that there's no government on either side, right, who will impose tariffs, right, that make the whole mutually beneficial voluntary trade to not be beneficial anymore. right? So there are no tariffs or no other form of trade restrictions that block trade or to make trade unfavorable. So these are the two assumptions. Now, of course, if you want to push this argument a little further and say, okay, but what's happening now in the real world, right? With US raising tariffs, right? How would this impact on trade? Well, many of the gains from specialization and gains from trade that are supposed to manifest based on the competitive advantage theory may not manifest, right? And some of the supposedly mutually beneficial trade may not occur, right? And if that's the case, then we lose certain gains from special. If we can't mutually benefit due to trade, we will not be specializing. If we won't specialize, then we lose all the gains from specialization that could have been. All right, so this is the table 3 to show both countries can benefit. All right, so that's the end of the explanation of the CA theory using a mathematical model, which you don't have to present in the exam according to the syllabus document. However, it is something important to understand the principles behind. So when you write in words, right, you need to be able to communicate this level of understanding, even if you don't draw out tables and use numbers, right? You must very clearly be able to communicate to the examiner, I know what's going on, right? Now, earlier, right, backtrack a little bit, we had said that the two countries arbitrarily agreed to export the goods toward each other at the rate of 1:10. How is that determined? Is it negotiation? It doesn't happen in a free market, right? The terms of trade, right, is actually determined by market forces. Now, what you see here, right, is a diagram that shows the market for guns in USA. So assuming autarky, assuming that the two countries initially do not trade, the equilibrium price of guns in America is determined by demand and supply intersection in the free market. So domestic demand, domestic supply gives us the intersection of this. What is the price of guns in America? The price of guns in America will be a certain number of US dollars. How many US dollars is the cost of a gun? Let's, for simplicity, assume that America doesn't produce a wide range of guns. There's only one gun, right? Homogeneous good. So that all guns are the same gun, right? So there's one homogeneous good. What is the price of this gun? There should be $1 value price, maybe 200 US dollar or 300 US dollar, for instance. I'm going to now quote the dollar value of the guns in America, not in terms of US dollar, but in terms of how many roses can this gun buy if we took the dollars to buy the gun to use it to buy roses instead. Now, I'm making a lot of assumptions. I'm assuming that everything is a perfectly competitive market. So in a perfectly competitive market at long run equilibrium, the price of one gun in America will be the exact number of US dollars needed to pay for 8 roses, assuming long run equilibrium in the perfectly competitive industry. So the price of one gun is equivalent to 8 roses, the market equivalent price at long run equilibrium, assuming perfect competition. Right? Note that a lot of assumptions inside CA theory. Right? Now, then what about Vietnam? What is the domestic demand and supply intersection going to give us? It's going to give us the equilibrium price in Vietnamese dong. How many Vietnamese dong is one gun? In Vietnam, it will be the exact number of Vietnamese dong needed to buy exactly 15 roses. Now that gives us an internal price, autarky price, right, in each country that is different, right? That gives us a range at which they now can be agreeable to trade. So America needs the price to be higher than 8R. Vietnam needs the price of one gun to be less than 15R. And where is market equilibrium? If the world only has 2 countries, right, the market equilibrium must be such that at this market equilibrium price, the quantity supply of guns in USA exceeds the quantity demanded by a distance that we call it a surplus. While in Vietnam, at this international agreed world price, right, the quantity demanded greater than quantity supplied by a distance which we call a shortage. Equilibrium occurs when this shortage exactly matches this surplus, right? Then we have a globe. Remember, we assume that the world has only 2 countries, so the total world market, right, is at equilibrium, right? Any higher price than this, I have a smaller shortage in Vietnam compared to the large surplus in America, then the world has a net surplus in the global market, and that will exert a downward pressure on price, and the price is going to come back down, right? But if I have a price lower than this, then America's surplus will be too small compared to Vietnamese shortage. This will lead to an overall net shortage in the global market for guns, and that will exert upward pressure on the price. So eventually, the world equilibrium price will settle at a level where it matches the shortage of the importing country to the surplus of the exporting country. Now, this is a two-country, two-good model. What if now I extrapolate to a good that is produced by 5 countries and imported by 10 different countries, right? Then the world equilibrium price must also be such that the sum total of the surpluses of the exporting country must be equal to the sum total of the shortages of the importing country at that price, right? So that we have a global market equilibrium. So the terms of trade that we showed earlier, right, that we arbitrarily decided as 1:10, right? In the real world, in the market economy, it isn't arbitrary. It's market forces that will actually determine where is the market equilibrium price. All right, so this is the way terms of trade are determined. All right, we can repeat this same terms of trade determination in reverse, in the other perspective. If we just draw roses in Vietnam versus roses in America, then America's price of rose will be 1:8 gun, 1/8 gun, whereas Vietnam will be 1/15. And the equilibrium terms of trade in terms of roses will be exactly 1/10, right? So the terms of trade here will be 1/10 guns in exchange, 1/10 guns, right, in exchange for a rose. All right, so this will be the terms of trade determination. All right, so with that, we finish the second key idea. Now, the third and last idea for tonight, which is something that Cheryl was asking me to go through just now, which is the how to use the graphs, right, to explain CA theory. Okay, so that's what we're going to do now. So to explain CA theory with the graphs, first take note, we are using what graph? We are using PPC graphs, right? So we begin with 2 diagrams, one on the left, one on the right. One is USA, the other one is Vietnam. Notice I'm using the same countries, same goods, guns and roses, right? So whichever country, whichever goods you use, just replace. You can superimpose the 2 graphs into one diagram, or you can draw it as 2. It's a matter of preference. I personally like to do it as 2 separate diagrams because it looks less messy. And you will see how it gets messy in a while if I add the lines. Okay, so let's learn to draw this diagram. If you can at home, if you are watching this as a recording, pause, right, and take paper and draw, right? If you are watching live, if you can, work really fast, sketch freehand, draw the axis. Okay, so first let's draw the PPC of America. Now, first notice the America's PPC is drawn as a linear function, not a curve like what we used to do, right? So what we're doing here with a linear function is we are reflecting the simplifying assumption of constant returns to scale. Are you allowed to draw constant returns to scale or straight line PPC in A-level econs? Pretty much the only chapter you are allowed to do that, right, is international trade, right? So in international trade, you are allowed to draw straight line PPC. In fact, you don't need to draw curve PPC at all for international trade chapter, right? There's no situation where you need to have a curve PPC. Not that it's wrong, not that it's wrong. It's just that it's a simplification that is really convenient, and I urge you to do that for all throughout this chapter. Other chapters, please don't do that. Other chapters, PPC, just use a curve. Right, so America's PPC is a linear function because of constant returns to scale. You can already now imagine Vietnam should be exactly the same as well, right? Now, however, right, notice the way I draw the PPC curves, the gradients are different. Right? America's PPC actually reflects my numerical table just now. So I'm using back my numerical table where America has, if it devotes all its resources to guns, it will make 200 guns. If it devotes all its resources to roses, it make 1,200 roses. But remember the assumption, simplifying assumption that each country initially devote exactly half its resources to produce each good. So America's starting point was I make 100 guns and 800 roses. Vietnam does the same. my initial position is half my resources to guns, so 40 guns, half my resources to roses, that's 600 roses. Okay, at this point, I want to pause here, do a bit of math. What is the gradient of the PVC of USA? The gradient of PVC, if you remember your math, gradient of a linear function is rise over run, right? Rise 200 over run negative 1600. Cancel, cancel, you get negative 1 over 8. And what about the gradient of this guy? Gradient of this guy again, rise over run. Rise is 80. Run, right? Run is left to right. So now we're moving in this direction. It's negative 1200. So cancel this. This will be 1 over 15 with a negative sign. Notice something about these numbers. These numbers, right, are 1 over 8 and 1 over 15, right? They are exactly the op cost, or at least you take away the minus sign. This is the op cost of producing 1 rose in Vietnam from the numerical tables earlier, and this is the op cost of producing 1 rose in USA. All right. Okay, so the key point I need you to remember now is this: the opportunity cost, the gradient of the straight line PPC in a PVC diagram, right, is a reflection of the opportunity cost in that country of producing the good on the horizontal axis, right? It is the opportunity cost of producing the 1 unit of the good on the horizontal axis, whichever good you choose to put on horizontal axis. All right, I have a question that popped in. Let's answer the question first. So Chloe asked, regarding the CA theory, can I say that one factor that allowed globalization to happen is the lower transport cost due to the technological advancements? Then CA theory does not, then because CA theory does not take that into account. Okay, I don't quite understand what's the second half of your question, but I get what you mean in the first part. So you're saying that one of the reasons why globalization happens, right, is because transport cost has been falling. So prior to the falling transport cost, right, the real world have such a high transport cost that prevented trade, right? They prevented some trade to have happened, right? But the falling transport costs allow more and more and more of the gains of specialization and trade that supposed to have manifest to actually manifest, right? So because of falling transport costs, then yes, Chloe, not only is that something that you can say, that is in fact one of the key drivers of globalization, right? Technological advancement that led to falling transport costs was and is in fact a key driver of globalization, right? So definitely you can say that. All right, continuing now. So I hope I addressed that point already. All right, so at any point you got any questions that you want to ask, just keep them coming and pop it into the live chat. All right, so this is the initial position of each country. The point I noted just now was the idea that the op cost of producing the good on the horizontal axis is shown as the gradient of the PVC curve. So the steeper the curve, right, when US curve is steep, right, that means US op cost of producing the horizontal good, right, the good on horizontal axis is high. That means when you are steep in your PVC, your CA lies with the good on the vertical axis. So America's CA was guns, right? So America's steep graph, steeper than Vietnam graph, tell us that America's CA is in guns. Vietnam's gentler gradient, right, suggests that its op cost is lower for roses. Therefore, the Vietnam special CA is in roses. So that's how you quickly connect the concept of CA to gradient of PVC. Steeper, then your CA is in the vertical axis. Less steep, your CA is in the horizontal axis. Try to remember that. All right, so now each country started off at the blue color point, and then remember from our table 2, we say, okay, Vietnam has a CA in roses, right? So Vietnam should specialize in roses. So Vietnam moves from one point on its PVC to another point on PVC. Vietnam moves to the extreme corner of the PVC to produce 1,200 roses, but 0 guns, right? America, instead of going all the way to full specialization, America only does partial specialization. Why? Because we needed that America to produce some roses, because 1,200 roses in Vietnam isn't going to be enough to give us just as many roses as before specialization, right? So we need the Americans to help out and make some of the roses. So because of that, America can only partial specialize and only do 150 guns. So now we have moved to the point, green color point. Okay. So now at the green color point, the two countries are ready to trade. At what rate will they trade? Okay, so I need to recap with you again. This is negative 1/8 radian. This is negative 1/15. What does this mean? In America, every time I give, without trade, internally, every time I give up one gun, I get 8 roses. Or every time I give up one rose, I get 1/8 of a gun. Vietnam, every time I give up one gun, I get 15 roses. Every time I give up one rose, I get 1/15 of a gun. So they have an internal rate at which they can exchange goods domestically. They say, okay, if we are to do better, right, we should get a better deal, right, from each other. So what's the better deal they can get from each other? So using the same example earlier, they get a deal where they trade 1:10, right? So that means instead of changing 1:8, we change 1:10. Now watch carefully, So Vietnam at 1,200 roses and 0 guns, if they were to give up roses, some roses and get guns, move back along the PPC, they will move along the blue line. But because they are now able to trade at a rate of 1:10, they are able to give up roses, but get more gun from every rose that they give up than if they do it internally. So by trading roses for guns with USA rather than internally producing less roses and freeing up the resources to make guns, the Vietnamese are doing better, right? By trading. So the Vietnamese, obviously being rational, will choose to move up this arrow and trade with the Americans. Now America, at the same time, where are they? Americans are at this point, right? They are at 150 guns and 400 roses. So there are two options here to get more roses. They either produce more roses on their own, right? Which means they have to sacrifice every rose, they sacrifice 1/8 of a gun, or they move along the red line and trade with Vietnam. Every rose they buy, they give up 1/10 of a gun. So you give up less guns for every rose. So obviously Americans, being rational as well, are going to choose to move along the red color path. This is called the trading line or the terms of trade line, right? And it has to be same line, it's the same gradient for two countries. Now, where to draw this line? So that's the crux to take note. Where to draw the line? The line must be drawn at the production point, right? The line must be drawn at the production point of each country. So Vietnam is at 10 guns, 120 roses. We start from here, we extend the trading line from here. America is at 150 guns and 400 roses. The trading line has to start from here and in the direction of what they wish to buy. So America wish to buy roses, then the line starts from here and move towards the rose direction. Vietnam is at this point, 0 guns and 1,200 roses, and they want to buy guns, right? So they must move towards the gun direction that is having fewer roses. So that's where you draw the terms of trade line. So now the final diagram. So America will sell 45 guns to Vietnam to leave them with 105, while they get back 450 roses to push them from 400 to 850, land them at this red color point. And Vietnam gains from 0 guns, gains 45 guns, but in exchange they lose 450 roses from 1,200 to 750. That lands them in this red color point. So now we can see the end point. Both countries end up consuming more guns. Both countries end up consuming more roses than before. All right. Last point before I answer Sam's question. Last point I want to emphasize here is a very, very crucial point. Notice how both countries' consumption point now, right, the red color point, right, is nicely sitting outside of each country's respective PPCs. That means, did my PPC shift? No, right? Did the quantity of resources in the world improve? No. Did the quality of resources in the world improve? No, right? Did technology advancement occur? Also no, right? It's just that there was a reorganization of which country produced which good, and then it's the idea of division of labor and specialization. So whoever is better at something makes that, whoever is lousy at something else makes something else, right? And then we trade. But here's the kicker, right? CA theory, remember we started off with USA had an absolute advantage over Vietnam in the production of both guns and roses. That means even when one country was better than the other country in the production of all goods, right? In the production of all goods, then we are able to show that we are able to get both countries become better off, and on top of that, both countries can consume at a point outside their PPC. So it's not a my gain is your loss, your gain is my loss. It's that we are both gaining, right? So where the gain come from? The gain must be an efficiency gain. That tells us that without free trade, the world must necessarily be productively inefficient. Right? Now, conversely, right, those of you who already learned tariff diagrams, right, and quota diagram for protectionism, remember when you draw tariff diagram, quota diagram, you have a deadweight loss, area A, area B, area D, deadweight loss. Where is then, what is that deadweight loss? That deadweight loss is the loss of efficiency, right? That means the gains from specialization did not materialize, right, when we impose tariffs and impose quotas to restrict trade, right? So this is the very important idea to take note of. All right, so now I have two questions lined up. Let's look at the first one from Sam. Is there a reason why the gradient is the op cost of producing one unit of good and not on the horizontal axis? Well, it's math, right, Sam? If you look at what let me backtrack here, right? If you look at the gradient of this line, mathematically, right, the gradient of the line is I take 2 points and I look at the vertical height over the horizontal distance, yes? So vertical height is number of guns I have to give up for every rows I have to buy. So if let's say I limit this to 1 unit, right? So delta X, right, is 1. Then here delta Y, based on this gradient, has to be 8, right? So that means the gradient, or rather, here is 1 over 8, rather 8. Delta Y here will be 1 over 8 based on my numerical example just now. So then, if this gradient is 1 over 8, what is saying that every time I make 1 rows, I'm moving in this direction. Every time I make 1 rows, I'm sacrificing 8 guns. So based on that understanding, it has to be the opportunity cost of 1 more rows, right? So mathematically, that's why it is always the op cost of the good on the horizontal axis. All right, so I hope that answers your question, Sam. It's basically just math. All right. Hang on, I got a text from Clara using a diagram. So what are you asking, Clara? How is this PPC diagram here different from the one you are explaining, as in both lines axis instead of from production? Okay, so Clara has, okay, Clara, I'll answer your, okay, what Clara has shown me, right? I don't know how to show this. I don't know if you can see this. Are you guys able to see this? Wait, I'm sure there's a way for me to do this. Hang on, let me play with let me play with this. Shucks. Is it sharp enough? Oh, got it. Okay, so this is the picture that Clara sent me on the phone. So she says that how come, right, the specialization is complete specialization in the diagram she's looking at. So I'm assuming, Clara, you are looking at this is probably from your school, right? What your school has probably done, right, is to use a slightly different numerical example. So instead of using each country has the same amount of resources to begin with and devoted equal amount of resources to the production of each good, right? What your school has done, wait, how do I go back to my previous screen? Right, what your school has, yeah, there you go. What your school has done, right, is to change the assumption such that it allows for complete specialization. Now that works, right? You can have a mathematical model like this, but that would mean that we have to tweak the initial numbers. We cannot let each country have the same amount of resources to begin with and devote half the resources. So that numerical example works perfectly fine. It's just that the starting point is a little bit messier to set up, but absolutely nothing wrong. So it's a different numerical example, Clara. So it works anyway. All right. So if your school prefer that way, that's fine. Jia Xuan asks, do we need to label the X and Y intersection of the terms of trade line? No, you don't really have to label the X and Y intersection of the terms of trade line, because that's just your production point, right? That's where your country is producing at. So let me just go back to the point. So this is your new production point, right? So the terms of trade line has to come from here. So where terms of trade begins is always at your new production point. So look, pay attention to the production point here and the production point here. The next slide will show the terms of trade line cutting through there. See, the terms of trade line connects from here, the terms of trade line connect from here. So this is where the TOT line extends it. I hope that's what I hope I'm answering your question, Jia Xuan. If I'm not, please follow up with another question. All right, Chloe asks, what's the most common question type regarding CA theory? There are two questions that come out in the essay for CA theory. The first question is, explain why countries benefit from specialization and trade. So using CA theory, the old syllabus would require you to draw tables and numerical example. The new syllabus said you don't need the numerical example, but wait, they said don't need, right? Doesn't mean they won't allow it. So if you want to do it with numerical example, that's perfectly okay, right? So the diagram method, right, would also be fine, right? If you draw the diagram method like this, you can also drop the values on the axis and just use the shape of the graph to explain. But that will be a little less rigorous, but you can, as I said, you don't have the numbers, but you still have to have the correct understanding and the way you explain your words. Like, oh, the gradient represents the op cost of producing one good at the horizontal axis. So if the PPC of USA is steeper, right, than the Vietnam's PPC, it would suggest that the opportunity cost of producing roses in America is higher than that in Vietnam. This makes America have a competitive advantage in guns. So you got to say all the correct words. All right. Wait. I got a question from Clara. 1 unit of resource in country B can produce 2 units of. Okay. Oh, wait. Country A can produce more cloth than country B. Country A can produce more wheat than country B, so that's correct. Suppose each country has 10 units of resources and devote with each to, okay, A. So country A, something is wrong, huh? Where is your table? Where is the table where is the pre-specialization? 5 units 50, 5 units 200, 5 units 10, 5 units. Wait, 5 units 20. Oh, that's 100, correct. Sorry, I'm looking at Clara's information. Can still specialize. Okay, anyway, Clara, I tell you what, I'll look at this after, I'll look at your thing after the live stream, because I'm looking at it on my phone. It's very small and it's a bit hard for me to digest this thing on the screen while everybody's waiting. I'll get back to you later privately. All right, so going back to Chloe. So the two ways that they are testing, right, is one, explain how CA theory, using CA theory, explain why countries, when they specialize in trade, it will lead to mutual benefit. The second way they test, right, is change in CA. So the one of the next week's lesson, right, in class, I'll be going through the 2015 Part A question, 2015 international trade question about the change in CA, how to explain what causes CA to change, or then from there we'll extend to this thing called the dynamic CA, right? So that's the other way they test. So it's about using CA to explain gains from specialization, as well as the other popular type of question is what can cause CA to change. And if you turn it into a Part B question, it can become a policy question and say what policies can the government use, right, to pursue a CA in a new area that they previously didn't have a CA in. So they can even turn it into a high order question. All right, so Sam, why is the green point the new consumption point at 1200 zero? No, that is not the green point is not the consumption point. Sam, the green point here is new production point for each country. So Vietnam has fully specialized in guns and not specialized in roses and produce zero guns because it has a CA in roses. USA, why did not go all the way to zero roses? Is because of the same reason that we had just now using the table method. Where we concluded, right, that if America were to send all its workers, right, that were producing roses to produce guns, then America producing zero guns, leaving Vietnam to produce 1200 roses, that will mean that the world has fewer roses than before. So we then cannot know, we don't know that the world is surely better off. So in order to show that the world is better off, I need to have at least equal or more of both goods. So if America and Vietnam both were to fully specialize, we will not be able to get more of both goods, right? So that's the same reason, Sam, why we draw the graph such that the green point, the production point, has to be not at the axis for America side. All right, I hope that answers your question. If not, please follow up again with another question. Cadence, would we use the PPC alongside the table or use it as a replacement? Replacement for sure, right? The PPC is another way of illustrating the same idea. It is not a complement, it is a substitute, right? The PPC and the graphs are substitutes of one another. All right, next we have JT. Do we draw the PPC graph or CA table in the exam? Because my school only teach CA table but not graph. JT, whoever you are, the syllabus says the numerical example is not required. So drawing the table is technically not required. But as I emphasize, you can draw. Not required doesn't mean it's not allowed. So theoretically, you can always just use table. But from experience, a question that asks for why countries specialize and trade and how this to mutual benefit, using tables, using graph work equally well. But a question that asks for change in comparative advantage, right? A question that requires you to say what can cause CA to change in a country, then graphs, the graph method is much easier to use than tables. Table will be very troublesome to show change in CA. So I would suggest you learn the graph as well for those questions. Right, so if you are my student, please, whether you're not my student doesn't matter. Please rewatch this video, right, as many times as you need, right, to understand how to draw the graph. All right, Sam, is it possible for Vietnam to partially specialize and not fully specialize? Sure, right, sure, right. But if I could, right, I will make both countries fully specialized. That will make life easier. But because I want to show more of both goods, right, I have to make one country partial specialized. If I want to make both countries specialized, partial specialized also can, but it just complicates my numerical example unnecessarily, right? So this is why we wouldn't do it, even though we can. All right, so then that's your CA theory. All right, so with that, I think we have finished up to the last slide for the main focus of this. I have one last slide I wish to talk about that is only for the more thoughtful students. This is a little bit more advanced stuff. This is not going to be tested in the A-level exam. Okay, so if you don't want to listen to this, that's fine, right? Because this is not tested. Our numerical example, right, that we showed that there was one set of numbers that showed both countries are better off as a result. Does this set of numbers, right, show us that when two countries trade according to the CA, there can be mutual benefits or there will be mutual benefits? That means I'm saying that free trade, am I able to conclude that free trade can be good? Or am I concluding that free trade is good? Assuming all my assumptions hold, assuming all my no transport costs, no tariffs, and all my constant returns to zero, assuming all those assumptions hold, right? And the numbers work out nicely. Did I demonstrate that free trade will surely be better, or am I saying that free trade can be better? Okay, so to answer this question, right, let's go back all the way to second table. The second table, right, is a table that we worked out to show that by getting Vietnam to fully specialize in roses and no guns, and getting America to specialize in partial specialize in guns and some roses, we now have more of guns and more of roses that show up in the world, right? So here's the question: will this outcome surely happen? Right? Will the free market end up always in exactly this situation? Then the answer is no, right? Free market may not surely occur like this. But if it did, right? If it did, is this outcome clearly better than no trade? Right? This outcome is surely better than no trade, right? Where no specialization and no trade. So let's call this outcome, let's give a name to this outcome. Let's call this entire outcome, outcome B, right? Outcome B is surely better than outcome A. Now, in case you don't know what this mathematical symbol here, this is not a greater than sign, and this is a greater than sign. This is a little bit curly, right? A little bit curly at the arrowhead. This shows that B is preferred to A, right? So outcome B is clearly better than A because outcome B, right, has more guns and more roses compared to A. What is A? A is the autarky state, right? So if outcome B happen, outcome B is surely better than outcome A. But is outcome B going to happen? No, right? So the actual real world outcome, let's call it outcome C. B is an outcome that could happen, and if it did happen, it's surely better than A. Now, if B didn't happen in a free market with voluntary free trade, then if B didn't happen and C happened instead, logic dictates, right, that C must have been a better outcome than B. So if B is surely better than A, and if B happens, we are happier. If B didn't happen, it must be some other scenario called C that is happening, and that logically has to be even better than B. Otherwise, the free market wouldn't have chosen C. Right? I'm again assuming no market failures, right? No market failure, no imperfect information, no externalities, right? And if that were the case, then C, which is better than B, must also be better than A. So therefore, the conclusion that we are making, right, is so this theory that David Ricardo came up with in 1817, right, it's not trying to tell you that using this mathematical model, we can show that when countries specialize in trade, it is possible that we get to a better outcome. No, right? That's not his theory's conclusion. His conclusion is very, very precise, right? Assuming these simplifying assumptions hold, even when one country is better than other countries in producing all goods, the world is better off. Right, the world is better off as long as we can identify that one country has CA in one good and another country has CA in the other good. Right, then we will show that the world will be better off if they can specialize according to CA and trade it. No matter how they end up trading, it didn't matter. They will always choose an outcome C that is surely better than outcome B that is surely better than the autarky state. Right, this is the power of the CA theory. All right, so if you didn't understand that, never mind. After A levels, if you are still interested, rewatch this video multiple times and think about the logic of what I'm trying to argue. If you got this, good for you, right? Okay, so now I got another question that showed up from Sam. Do we need to explain the price mechanism if we talk about equilibrium terms of trade, or do we talk about, or when do we talk about equilibrium terms of trade? Okay, so Sam, good question. Thanks for asking that. When we are using CA theory to explain why there are mutual benefits, right? We simply we identify the range of terms of trade like this that we see on the board here. So we just need to identify this, and then we arbitrarily assume a number. So when do we use these terms of trade? If you look carefully at the terms of trade diagram, right, you should realize this diagram looks a bit familiar. Which is the importing country now? The importing country is Vietnam, right, for guns. Can you see this is basically your SW, this is your world price, this is your importing country, right? This is your quantity of imports, this is your locally produced goods, right? So then from here, if you impose tariffs, right? So this diagram that you are looking at is, when you draw a tariff diagram, we are actually literally using the importing country diagram. So when do we use this diagram? When doing tariffs and quotas. The other time that we use this tariff to use this two diagram to look at changes in terms of trade, right, is when we talk about changes in pattern of trade, right? If the country says, if a question says, how to ask you to explain how a country's pattern of trade might change, right? How come sometimes your country, previously your country would import this good but export that good? Why now, right, is changing to import a different good? So for example, let me erase all this extra stuff. So imagine now, if there's a technological advancement in your country that causes your supply curve to shift in Vietnam such that the internal price, right, becomes 1G equals to 6R, which is now lower than USA's 8R, right? Then the new equilibrium terms of trade must fall somewhere between 6R and 8R, right? So maybe 1:7R. Then now Vietnam becomes the exporting country, US becomes the importing country for guns. That is how a change in CA can be illustrated using a terms of trade diagram, right? To show that Vietnam gaining CA in guns while losing CA in roses, right, will be shown as a rightward shift of Vietnam's supply curve, because the lower CA, gaining CA means lower op cost, right? Lower op cost will translate into lower actual cost of production at long run equilibrium, assuming perfect competition again, right? So that is the reason behind. That's how we present this. Use this table. Okay, so Sam, I hope that answers your question. All right, any more questions? Any questions, please shoot. All right, so while waiting to see if there are any more questions, I recap again. In the A-level exam, the syllabus do not require you to use numerical example. But it doesn't say you're not allowed to use. This is why some schools, most schools, right, continue to teach the numerical example, drawing the table. But I think most schools also tell you that it's not required, right, for the exam. But at this stage, I think most teachers don't exactly know, including myself, don't exactly know what Cambridge wants, right? If they ever set a question like this, then what level of detail do they want? So most of us are, feeling a little bit apprehensive. We say, okay, now my play is safe, right? If I was advising my students, I'll say if a question comes out that asks you to use CA to explain trade, I'd rather use that example anyway, right? Use the numerical example, overkill a little bit. After all, right, your seniors were able to do it within the time limit. So why are you not, right? Okay, so JT asks, is pattern of trade considered dynamic CA? If so, which diagrams do we draw? The equilibrium TOT diagram or the PPC diagram? I would say, okay, pattern of trade is outcome in terms of how we trade. CA is our comparative advantage. So when my CA changes, my pattern of trade changes, right? So let me add a slide here. Change in CA will lead to change in pattern of trade. So when you want to show pattern of trade change, using demand supply diagram will be helpful. If you're showing CA change, then using PPC, right? Use PPC diagram would be more suitable. However, what else can change pattern of trade? There are also other things other than CA change can change pattern of trade. For example, right, you can talk about how free trade agreements, right? So signing of or expiration of free trade agreements can change this. Changes in transport costs, right, due to either technological advancement that lower transport costs, or maybe disruption to shipping, right? Maybe the Suez Canal have some disruption, some ship got stuck and causing boats to get stuck at the Suez Canal and trade cannot move. All this translates into transport costs rising dramatically, because then ships have to sail all the way down south and loop around Africa to come to Asia, right? Then all that adds like 18 days more to shipping, right? So that will add tremendous cost. So all these can be things that change pattern of trade, but they're not CA, right? Then if you talk about things like what if your country got increasing factory mobility or decreasing factory mobility for the matter, then that's changing your efficiency, but not changing your CA. But if your factory mobility is rising, right? Your factory mobility is rising, it is helping to your CA to manifest better. Then there is still not a change in CA, but a change in pattern of trade nonetheless. So there are many things that change POT. So to answer JT's question, to explain POT change, DDSS diagram will be the most suitable. If you are simply explaining CA change, then PPC diagram. So if you are explaining CA change causing POT to change, then of course DDSS. So if the question says explain what can cause CA to change, PPC diagram. Explain how a change in CA can lead to POT to change, then I will use DDSS diagram. Okay, so JT, I hope that answers your question. All right, do we have any more? Hi, Joshua. Joshua came late today. I don't know if Justin is still around. Okay, do we have any more questions? Okay, I think that looks like it's about it. It's 10:17. I'm already 17 minutes overshot. So sorry for the extension, and thank you very much for your time. If you got any questions to ask, again, as usual, text me, ask me, or if you're not my student, type in. Oh wait, I have one more question. Sam says, when you say a numerical example, are you referring to the CA table or graph? Both, right? CA table or graph. As long as it's got numbers, it's a numerical example, right? As long as you got a got the numbers, it's called a numerical example. So obviously, you cannot draw a table with no numbers, right? So if you're not using numerical example, you cannot use table. But you can still draw your PPC graph without numbers, right? That will be fine. Okay, bye, Chloe. Hey, Chloe, the question you asked me that day about referral, I think you got it already, right? Shirley contacted, settled with you, right? If not, can you text me and let me know again? Check with me again. Okie dokie. Good night, everybody. Thank you for your time. Have a good night's sleep. Don't sleep too late. Bye bye.